Android tool chains as well as the iPhone tool chains, and for each platform, we'll build a simple Hello World project, and then we'll take a look at how Titanium interacts with those native SDKs, and then there are some lab exercises I'll point you to at the end. To start with, we're talking about tool chains, and everybody has one. A tool chain, in our definition at least, is a set of executables or scripts that work together. They're going to take your code from source code to a finished distributed application. In a more specific sense, toolchain is going to include some sort of project manager that you will use to create the project, maybe set some configuration details. There'll be some sort of editor for editing your source code, a compiler to convert it into runnable code. Typically, there are debugging tools to help you detect errors, find memory leaks, and so forth. Especially important in the mobile world, there will be some sort of simulation engine. It's difficult to get your apps onto a mobile device in some situations, and it can be faster to simulate that right on your desktop or laptop. Finally, toolchain in the mobile world at least includes some sort of packaging and distribution tools. Both the Android and iOS markets require you to code sign any applications you distribute, and their SDKs include tools for doing that. We'll start first by taking a look at the Android toolchain. There are a few scripts that we'll go through. Now we're working in the command line environment here, separate from Eclipse. The typical Android developer would be using Eclipse with the ADT, Android Development Tools plugin, that would end up rolling up many of these functions behind some graphical wizards and so forth. But these are the tools that are actually shipped with the SDK, and we'll see how they interact, and then also see how they are used within Studio, which is going to provide that same sort of plug-in environment that ADT and Eclipse would. But in any case, the Android script on Windows will be called Android.bat, and on Linux and OS X it is just the Android script. This is our project creation tool. It's also a handy tool for updating SDKs and so forth. The editor can be just about anything. Now again, the folks from Google are going to expect that you're using Eclipse, but you could use TextMate or Notepad or whatever text editor you want to edit your Android code. The compile is done by the Ant build scripts and then ultimately the Java compiler. In terms of the debugging tools, there are a few. The most important that we'll be using or that we'll care about here are the Android Debug Bridge and the Dalvik Debug Manager. DDMS. So ADB is essentially the link between your desktop operating system and either the emulator or the actual device on which Android is running. It is a link between those two worlds. DDMS is a debugging tool that will let you monitor and manage both the emulators or rooted devices or even non-rooted devices in some ways that are connected to your computer. For the simulation emulation environment in Android, it actually uses an emulator. So it's going to emulate a full set of hardware and then run a version of Android within that emulated hardware. This would be done through the Android Virtual Device Manager, which is part of the Android tool that I described before. And then the actual executable is called the emulator on Windows, emulator.exe. And then there are various tools that are used to code sign, jar signer, and key store, and so forth that are part of that. Again, we'll take a look at those. We'll save most of the in-depth look at packaging and so forth for the final lesson in this course where we talk about how to get your apps into the market. Let's take a look at what's in the box with the Android SDK. Let me flip over to Finder. Now I'm running on a Mac. Depending on your operating system and the version and when you installed and so forth, the SDK is going to be located in different spots. The Android SDK is pretty much just provided as a zip file that you can unpack and put wherever you want. Back when I did this, I chose to put it in the root directory of my hard drive. Your mileage may vary. So here's my Android SDK. There are in there a few folders that I want to take a look at, starting with the platforms directory. You'll notice in here I have various versions of Android identified by the number at the end, the API number. These roughly correspond to a released Android version, though obviously they don't have the same sorts of numbers that you would see in a consumer space. For example, Android 15 is going to be one of the 4.x versions, the ice cream sandwich releases of Android. You can take a look at the Android tool to see how these correspond directly. Now, Android is interesting in that it is released as kind of a generic operating system that could run on just about everything, and then there is the mobile version of it. So when I teach this class live, I joke that the Android that we're looking at here is Android for refrigerators. This is the generic version of Android that really does not have any of the Google add-ons that you would expect in a mobile device. When I go over to the add-ons directory, you'll notice that I have a series of directories that have those same sorts of API numbers. So these correspond to the same versions, but these are the Google API add-ons, and these provide functionality like account synchronization, Google Maps, Google Docs links, and all those sorts of things. These are all of the add-ons that turn that generic Android for refrigerators into an Android for a mobile device. You'll see this play out in Studio when you go to build a project for Android. It's going to ask whether you want to build for the Google APIs version or just some other Android version. Always make sure to choose the Google APIs version because we're building a mobile app. We're not building Android for refrigerator sorts of apps here, so that generic form of Android wouldn't really apply. So let's see, next we'll take a look at, there are these tools. These are various tools that are used for interacting with the SDK as well as for the emulator itself. Here's my emulator. This script kicks off the other ones here. I have an ARM or an x86 based emulator for running my applications as I'm developing. Here's some of the development tools. There's the DDMS debugging tool and so forth. These are the scripts that are used behind the scenes by Titanium or Eclipse with the ADT plugin. There's also the platform tools. Google divides some of these out for reasons known to them. For example, ADB I described as that bridge between your desktop operating system and Android that lives in this platform tools directory. Let's take a look at how you would create an Android project using this native tool chain. And for this, we're going to be digging into the command line. So we have the command here that we would use to actually create an Android project. I'll bring over my terminal here. So we're going to create one Android create project. Now it can't be on multiple lines as shown on the slide. Okay, so I'm going to do a target. Now this is the API version, essentially the version of Android that I'm going to be building to. The number is going to be specific to your system. In this case, I have target 8 installed on my computer. You'd want to make sure. Let me go back here. Android, I believe it is list targets. Will tell me all of the versions. So you can see these numbers along in here. So here's my Google target 8, gives me an API level and the version of Android to which this corresponds. Clear that out of there. Android create project target 8. So there's my API version that I'm building to. I'm going to give a name for my project, and I will enter a path to my project. I'm going to store it in my current directory in the Hello World Android folder. All Android projects have, or all Android apps have an activity. This is basically the runnable context on Android, or an activity is essentially a screen that the user would interact with. We talk about activities more in the advanced course. So activity, and we'll call it my app activity. We'll see our app is going to be named for that when it's finally installed on the emulator. Finally, we have to give a package name, which is going to be the unique ID, the app ID, as we saw in Studio in the first one. So com.app.myandroid. This would be in that reverse domain name scheme that I described before. I hit enter, and there we go. There's my output. I'm dropped back to my command prompt. Okay, clear, so you can see what's going on here. All right, so here are some projects, or so the files. So we get a couple of directories like res and source, resource and source. These are the directories in which my project files will be. Bin is where the built binary files will end up being. Android manifest is the main configuration file for my project. If I wanted to set its version number or hardware resources that it would be using, I would configure those in the Android manifest. Jump back over here. What these slides are showing, well, it's easier to demonstrate. Let's start by going into the res directory, and then you'll see there's a couple of different resources available here. Layout would be the XML files that describe the layout of my user interface. There could also be graphics in here. And then I'll have a main.xml. This is going to be my main window. If I had additional windows or if I wanted to break up my application in other ways, I would have multiple XML files for this. I have TextMate installed, so I'm going to use that main, not mail, main.xml. And then it popped up off screen, so I'll bring it back on screen here and zoom that in. This is the XML file for my main window in my application, and it's going to be composed of a text view, so just a basic label, in a linear layout. So it'll be a vertical layout that's going to fill the parent object. And notice this message here where it's going to say hello world and then my app activity. This was the name we gave to the activity. So I'll change this to video viewers so that we'll be able to see a change. This is, you would either enter the XML directly in here to lay out your application, or more likely you would use one of the layout tools provided by Eclipse or other tools provided by Google to draw out your application's user interface in this case here. So I will close that down. We'll come back over here. Go back to my root directory. And then this time I'm going to go into the source directory. And you'll see a series of directories that correspond to that reverse domain name scheme that I set up. So here we go. We're in com.app.myandroid. And then here is the Java file, the source file for my application. So again, my app. So we'll open this up in TextMate. Again, it chose to open that up off screen. Sorry. We'll zoom this in. And this is the Java file that is going to be the bootstrap for my particular application. As I mentioned, every application has an activity, and the way this is borne out in the code is that my app activity is extending the base activity class, and then whatever code I would be implementing in my file would be saved here. Since this is not a Java class, I'm not going to really go into any more depth than this here, and we'll close this down and we'll go over here. Let's go back over to my slides. Okay, so when we're ready to run our application, we're going to use the ant command, and then that'll call out to the build script, and we're going to build in debug mode. So again, let me go over here and go back to show you we're back at the main project directory here, and we're going to do ant debug. And it will go through a series of steps to build, and then what we're looking for is this build successful line down here, hopefully. Otherwise, you would get some sort of code error if you had some sort of syntax. And now when I go into my bin directory, you'll see that I have some built applications over here. Here is my debug APK file that will be installed, the myandroidapp.debug.apk. This is what I'm going to install onto the emulator to be able to run my test application. So we have to create a virtual device into which we will run our applications. I actually have a couple of these going, so I will just, or I have a couple already. I will bring up the tool just to demonstrate the Android tool. Let's see, I don't want it to go, I'm not going to do any of the updates. It's telling me that there are various updates available instead. So this is where you would update the versions of the Android SDK that are installed on your system. You want to make sure to grab this Google APIs, but you can generally ignore the samples or the documentation because those would be for native development. If you're not going to be doing native Android Java programming, you don't really need those samples. Here I'm going to go over to the Manage AVDs choice. This will bring up my list of Android virtual devices. These are the emulator configurations that I have created on my system, or any of the ones beginning with Titanium were created by Studio for me. So here's my Hello Android. I can edit it and show you. I get to choose a particular version of the operating system. Again, when working with mobile devices, make sure to choose the Google APIs version as opposed to the corresponding plain old Android version. I could choose the size of my SD card. I can choose the size of the skin, the screen resolution that's going to be displayed. And I also have hardware emulation here. I could bring up this list and choose some sort of hardware emulation. Again, Studio does this for you, but perhaps there's some sort of feature that you want to be using within your app. And if the default virtual device did not include, for example, device RAM support, you wanted to give your emulator more memory or something like that, you could come in and adjust that sort of setting in here. So I actually have an emulator running, so I'm going to quit out of this and bring in my emulator to show you that that's running. Happens to be running a relatively small skin, but there it is. Okay. And I want to go back over to my right tab. We're going to, let's see, I showed you the device parameters live in the Android tool, and now we will install our application here using the ADB install command as shown here. I'm actually in the bin directory, so I'm going to do ADB install, and it's going to be my Android app debug.apk. We see some transfer messages here. Oh, it already exists on my app, on my emulator, so I should remove that. So much for staging this sample before I recorded the video. Go into the applications, manage my applications. Okay, and there's my activity, which I will uninstall. Okay, let's try this again. Hopefully I got the right one. There we go. Now we see success. Back over to the home screen. And this one is going to be called My App Activity. Oh, I have multiple ones here. Am I going to guess the right one? Yep, there we go. It's really small. Sorry, it's hard to see. Hello World Video Viewers. Little trick here. We can open a telnet session to our emulator here. So it's on localhost. And then I'm going to need the port number, which is the number up here in the title bar. So 5554. Okay, and then I can do a window scale. Now typically what's going to happen is this emulator is going to be way too big for your screen. So you'd be making this smaller. So you would have some number, some fraction smaller than 1. But I'm going to make this bigger so it's easier to see. So I'll do 1.5. And then, whoops, it jumped off screen. But there we go. Now my window is larger so that you can see it is scaled up my emulator window so that I can see. Hopefully you can see it says Hello World Video Viewers. There we go. We'll quit out of that. And then I'm going to exit out of Telnet, and I'm all set on that. We'll jump back over to the slides. And there's the slide showing you what I just showed you live. So DDMS is the debugging tool that I mentioned. We'll go back over and bring this up. All right. So DDMS, any emulators or devices you have connected would be listed here on the left pane. You could have multiples all at the same time. In my case, I have just the 5554 emulator. I get a view onto its error log or its output log down here. or I can watch. Now, if you're doing your Titanium development, you can create a filter so that any of your ti.api.info type calls, you would be able to see those. Also, any messages put out at a debug level or an info level by the Titanium APIs themselves, they are going to be prefixed with a TI API sort of prefix here, a little string. So you can create a filter for anything with TI API, and then only those messages would show up in the list. Now we're not doing Titanium stuff right now, so we don't see any messages, but you can do that filter to help paw through some of this text that comes out, because it can get pretty long and complex. One of the things that you'll use this for, we'll see this in the lesson on location services, is the Android emulator does not know of a particular location when you fire it up. So I can set manual controls here on that emulator control tab. I can give it a latitude and longitude so that I can plot my current location on the maps. You can also simulate incoming phone calls or text messages and so forth using this. This is also the tool you would use for some memory debugging, finding out if you have a memory leak. So that's DDMS. It's a tool that you will probably use quite frequently when working with Android. Okay. So that's the last of what I was going to cover for Android. Let's take a look at the iOS tool chain. In this case here, Xcode is going to be pretty much it for everything. There are some command line tools, but for the most part, everything is done with Xcode, and the command line tools are really just there in the background for Xcode to use. So Xcode is going to be our new project wizard. It has a built-in code editor. Sorry, you can use whatever you want. You could even use something like TextEdit or something if you wanted to, but Xcode does have that capability built in. The LLVM compiler is what's going to be used to actually turn your source code into compiled code. And then there is the debugger, the LLDB debugger, though that isn't really used directly. You would use the instruments tool or one of the other tools built into Xcode to do your debugging. Unlike the Android environment, iPhone or iOS development uses the simulator as opposed to an emulator. In this case here, your project code is actually run in a simulation environment within the OS X operating system. So in a small sense, your application is cross-compiled to OS X in order to run. You don't get the full hardware emulation like you do on Android. Now the plus side of this is that it's much faster. The iOS simulator is very fast. It's quick to build and launch and test out your work. The downside is that it's not necessarily as accurate in terms of representing the final environment. And you will find things that will run in the simulator that won't run on a device or vice versa. And that's really just a case of the way the simulator works. And then in terms of packaging your application, Apple certainly throws some challenges your way in terms of code signing and getting certificates and so forth. We'll go over all the particulars of that in the final lesson of this course. So what's in the box? Let's take a look at what's in the iOS development box. Again, my Mac is a little bit older here, and when I installed, the tools went into the root of my hard drive. Nowadays, they'll go into your home directory, but they will both be contained in a developer folder. So in my case, the developers at my hard drive root. In yours, it will probably be in your home directory. Inside the developer folder, you will find various tools. Let's start with the applications. This is where you're going to find things like Xcode or the Dashcode editor. This is where the executables are located. There are tools down in the user bin directory. These are the command line tools that are used behind the scenes by Xcode. For example, the compiler tools. Here's the LLDB compiler, LLVM, or LLDB debugger, sorry, LLVM compilers. One of the ones that we're interested in Titanium Studio uses the Xcode build script to actually call out and build your Xcode project when you do so through Titanium Studio. Okay, so that's what's in the box, so to speak, with the iOS development tools. And let's take a look at how you would build that. I'll launch up Xcode. Okay, and I want to bring the Welcome to Xcode screen here. I'm going to create a new project, which again popped up off screen. Not sure why it's not putting anything on my main screen here. The iOS development tools, when you download these development tools, you'll get both the iOS and the OS X development tools. So you want to make sure you're going for iOS. And then you have a choice of a couple of different templates. Typically, people would choose either the tabbed application or the single view application template. I'll choose the tabbed template. This is kind of like the studio wizard that we saw before. We're going to provide a name, so I'll call this Hello World and give it a company identifier. This is the base of that application ID, that bundle seed ID. This would be the reverse domain name for your company. So in my case, it's already filled in as com.appcelerator. You could fill in whatever. I can choose the device family that I'm going to go for, iPad, iPhone, or Universal. A newer feature is this use storyboard. Older versions of Xcode did not use this storyboarding tool, which I'll demonstrate in a little bit. You created your layout files directly. Those files are named with an XIB extension. For historical reason, they're called nib files. The nib files contain the XML that describes your layout, just like those XML files we saw for Android. We're going to use the storyboard, so I'll click on next, and it's going to ask me for a location, and I will stick that in my home directory. All right. After a second, it brings up, now here's the info plist editor. This is like that tyapp.xml graphical editor. I can use this to change the version, orientation support, my app icons, launch screens, and so forth. So let's take a look at how you would lay out your user interface with this. I'm going to go over and select, let's see, I'll go to the iPhone storyboard file here on the left. We can see here's the tab bar controller. This is the wrapper for the various tabs. And if I scroll over here to the right, you can see, so this is the storyboard view. It gives you a flow diagram, kind of a wireframe through your application. I can select one of my views, and in my view you can see I've got a text label and I have some sort of text view. Okay, so in my view I could add additional components. Down here on the right, depending on what your drop-down list is selected here, I have objects selected, and I'm using this show the object library button, this third one over. From here I can drag and drop various controls, like I can have some sort of two-part segmented control button. I could modify that, but I got a first, second button. I could have some sort of slider, for example, up here. Notice I get nice little alignment lines to help me lay out my UI. Now the same sort of thing is possible with Eclipse and the graphical tools for creating an Android layout. I just didn't demonstrate that particular functionality, but here in Xcode we get to see this here. I will save this, and I'm going to build for the iPhone simulator up here. There are separate storyboards for the iPhone and iPads. You want to make sure you're building to the correct one. And I'm not showing too much of the code here. If I go to like the .h or .m files, here's the code that would be behind those UI controls. So I would rig up my UI, and then I would actually implement the functionality in the Objective-C over here. So let me go back, go to the iPhone storyboard, so I'm looking at the correct one, and I'll click on Run. And then it'll take a moment, but there we go. So here's the UI. You can see it in the background, and here's laid out. Now it doesn't do anything because I didn't actually code anything up, but I can actually demonstrate that I did build this particular UI. Okay, so close that. Back over here, so we saw that. Talked about the storyboard editor. You do have to kind of drill down. You select the storyboard, you select the view you're going to modify, and then once you have that, then you can drag and drop the objects out onto the storyboard. So this is a little bit different than the older nib editor for the files prior to Xcode 4, but it's still very functional, and that storyboard's very handy, as I mentioned. Then we run our application, and we saw that. Instruments is a debugging tool similar to DDMS, and it lets you look at memory allocations and objects that are created. At least for Titanium, it offers a little bit better view into what's going on in the memory. You can actually see the actual named objects, so you can see the various Titanium objects that are being created as your app runs. Makes it relatively easy to discover memory leaks or problems where you're allocating objects and then not removing them later. We'll demonstrate how to do that in our advanced course, but know that Instruments is one of those apps that you will likely use as part of your debugging with Titanium development for iOS. So we showed all these tools, and you're thinking, well, geez, I want to learn Titanium. I don't want to learn the native tools. The thing is that Titanium itself does rely on these native development tools. Our Python scripts call out to the mobile SDK tools, so they're going to call out to either Android or iOS build scripts, and then they're going to build your final native projects. So you do need to have those native SDKs installed. The Titanium SDK is dependent upon them. And because of that, it does mean also that you have to adhere to the platform requirements of those particular native tools. And this is why Titanium for iOS development requires a Macintosh. It's because Apple releases their native development tools only for OS X, and we need those tools, so therefore we need OS X. You will occasionally use some of those native tools, especially the debugging tools on occasion. It's handy to use Xcode to do things like add in support for custom fonts or set device permissions, and same thing that I showed in terms of modifying the Android manifest and so forth. So you will need to know those tools occasionally.